Okay, so today we're going to look at adding and subtracting rationals or fractions. So, no, we looked at multiplying and dividing and comparing. So today we're going to look at adding and subtracting. It's not much different than what you did in grade 8, but you guys don't remember most what you did in grade 8, except for the fractions are. You have some more proper fractions, you need to turn to improper fractions, and the numbers are a bit harder to work with, bigger numbers. Okay? This is the second to last lesson. On Monday, you've learned everything so far you need. On Monday, we're just doing bed mass kind of questions with fractions. Alright? So Monday will be the last lesson for this unit. Then on Tuesday, we'll do a review and a test. Alright? And then on Thursday, when I see you again, we'll be starting on our final unit before spring break. Probably take us entire.
How many units are we do? 6?
6, I think, yeah. Yep. The next one is actually 2 units of 1 after this one. I call them units 3 and 4. Okay. Adding and subtracting rationals, fractions. Okay. So when we're adding and subtracting, we need to find the lowest common denominator. So we need to make the denominators the same before we can add it. And we, just like we did with multiplication, we find positive pairs of 2 negatives. And it's a little bit trickier with adding and subtracting, and we'll go over those. Alright, so dealing with negatives. Oops. Come on. Dealing with negatives. So if a fraction has multiple negatives, find the negative pairs, right? And if the number ends up being negative at the end, move it to the numerator at the top, right? And convert any mixed fractions to improper fractions before we add them, all right? We'll talk about the negatives, joining the negatives. There's a lot of students make some mistakes on that. So a simpler question to begin with is the first one here, right? Our first step is to cancel multiple negatives if they exist on a single fraction, and here they don't, so we don't have to worry about that. Next thing we need to do is, before we can add, common denominators need to exist. So we have a 4 and a 2. What would the common denominator here be? No. So common denominator is what number can both of these multiply into? 8. So 8 is a common denominator, and we can definitely use 8, but it's not the lowest. 4, right? Right? So there's nothing wrong with using 8. If you ended up using 8, it just means your final answer, you have to do one extra step of simplifying, which your number is going to be a little bit bigger than it should be. So our common denominator here is 4. Because 2 can go into 4. 4 times 1 is 4. So all we need to do is multiply the second fraction, top and bottom. You remember, it's always the top and bottom. So I'm going to rewrite this, and I'm going to get negative 3/4 plus the second one. 1 times 2 is 2, and 2 times 2 is 4. Okay. Now we can add them. So who remembers what happens to the denominator when we're adding and subtracting fraction? It stays the same. So the denominator does not change. We started off with a 4. We ended off with a 4. Okay. What do we do with the numerator? Yes.
Can you move the negative out, or does the negative have to stay?
What do you mean out?
Like to the final product.
No, that trick that we did is only for multiplication and division. So that negative stays with that number. So we have a negative 3 plus positive 2. That's how we read the top, which would be negative 1.
Okay, so you're just adding. That's not hard.
All right, so negative 3. Negative 3 on the number line.
It's more like you're
We're adding 2. 1, 2. Where do we end up? At negative 1. All right. Okay. Not too bad? Okay. Now, on this question here, we've got a whole boatload of negatives. Right? And so we need to pair up the negatives to make positive. Now, when multiplying, everything is like one term. All those negatives apply to every single number. When adding and subtracting, it's not the same thing. You can only cancel out negatives that exist on the same fraction. Like I can't take this negative and pair it up with this negative over here to make a positive. That doesn't work. The only negatives that I can pair up have to exist on the same fraction. So I can pair up this negative with this negative because they exist on the same fraction. So those two cancel each other out. Right? But there's nothing else I can cancel out. This negative belongs to this fraction preceding it, or minus sign, yes.
Would it become positive, or are you just canceling them out?
Yeah, two negatives cancel out. I say cancel out. They do become positive, right? Right? So these two negatives are not, you can't combine these two to make a positive. This negative belongs to the fraction right after it. Okay? Yes, Chloe.
So the 1 and the 5, that would become positive, right?
Yeah, so I'm going to rewrite this so it looks a little bit nicer.
So can you take that negative from that bracket one and compare it to the positive?
So can I take this negative?
Yeah.
And compare it to where?
To the inside of bracket.
Yes, you can, but there's nothing to compare it to. Inside is just a positive. Now, yeah, we have a question later on, which we can do that, and I'll illustrate that point a little bit better. Okay? So, last question was adding two fractions. This time we're subtracting two fractions. The process is the same, right? We've canceled out the negatives. Before we can proceed, we need to have a common denominator. What would that be in this case, Tania? 20, yeah. So we have 4 and 5. The common denominator is 20. So I can multiply 4 times 5 gives me 20. And whatever I do to the bottom, I got to do the top. And multiply this by 5. Right? So this becomes negative 15 over 20. On the other one, I need to turn the 5 into 20. So I multiply it by 4. And I multiply it by 4. So this becomes 4 over 20. Okay. Now I've got to combine these two fractions together.
So you add them?
Okay. Well, add, subtract, it means sort of the same thing. All right. So yes, Renee.
Would it be minus negative 19 over 20?
Yeah. Yeah. So we have 20 here, and the top is negative 15 minus 4. So negative 15. We're subtracting 4, so we're going further down this way on the number line, so it becomes negative 19. And that's it. Now, when we're doing adding and subtracting, we should always check your final fraction here and see, is it simplified? When we do our multiplying and dividing, the technique we do with the crossing out and simplifying sort of almost guarantees that our final product is the most simplest one unless we made a mistake. Here, our final number here may not be the most simplest form. So you should always check it and reduce it if you can. So, oh, that was a horrible combination. Makes it hard to see. So these ones, can either one of them be further reduced? No, right? But it's something you should always check, right? Sometimes you can, sometimes you can't. Okay. So the only way I can increase the difficulty here is by giving you mixed fractions here. All right? That's easy, says Chloe. So our step is to convert our mixed fractions into improper fractions. And what would the first improper fraction be?
Negative 8 over 3.
Negative 8 over 3. So the denominator stays the same. For those who don't remember, right? We did practice on it. We multiply the denominator to the number up front. We add the top. 3 times 2 is 6. Add the 2, gives us 8. Throw in the negative, which is a negative. Yes?
Would the other one be 19 over 10?
It would be 19 over 10. So the next one, the denominator stays the same. 1 times 10 is 10, plus the 9 gives us 19, with a plus sign in between. Okay. Now, can we simply add these together? Are we ready to go? Yes, Chloe loves this, huh? Okay, Chloe, what do we got to do?
We're gonna make the denominators the same.
And what number would the denominators need to turn into?
30.
30. All right. Okay. So the first one, 3 times 10 gives me 30. So I multiply the top and bottom by 10. So that gives me negative 80 over 30. Next one, 10 times 3 gives me 30. So I'm going to multiply the top and the bottom by 3. So 19 times 3, 20 is 57. Yeah, thank you. 57 over 30. Okay. Let's see. Let's pick on somebody new. Ah, somebody new. What's the denominator for the next one? Let's see. Okay, Renee. What's the denominator? 30. Okay. What's the numerator? Negative 23 says Caitlin. Do people agree or disagree with Caitlin? Oh, sorry. Oh, sorry. I'm getting the. Yeah. Sorry. Negative 23. People agree, disagree. Renee disagrees. What do you think it is, Renee?
It would be like minus negative 137. Whoa. That's what I got. But if we're adding, doesn't it go that way? If
Yeah.
adding a negative, to go like up. Oh, I was multiplying. No, it's adding.
All right.
This question's adding. The one time I multiplied.
Yeah. So I threw it out there because lots of people make mistakes with it. Haley was right.
I knew it was going that way, but I didn't know the answer.
Yeah. So it's negative 80. No, I purposely asked the question. I knew she was right, but you add 23, you're moving this direction.
Yeah.
So
I need like 5 to 7 days mistakes before that.
So negative 23. Thank you. Okay.
Do those ones too.
Yeah. Do these two by yourself, and I'll help you on the third one. And I'll slowly put up the answer. So if you are struggling with this, just look up on the screen. But I think most of you got this. So I'll put it up. All right.
Wait, are we doing them right now?
Yeah. Do the top two, then we'll talk about the third one together.
I forgot one thing. Would you go the other way if you can't go that way? What?
We're not cross simplifying. Common denominator.
Oh my gosh, I was multiplying again.
Yeah.
Mr. Dolan,
Yeah.
the second line is the like is that a subtraction sign or is it a minus sign?
Well, the two subtraction signs become a positive. If you subtract a negative number, you end up adding a positive number. All right?
So is subtracting sign the common denominator?
Same thing as adding. Okay. Questions? Renee?
I thought we were subtracting that one.
The right one. Well, we have two negative signs. A negative and a negative becomes a positive.
Okay.
Well, a subtraction and a minus a negative sign become a positive. Or you can think of subtracting a negative number.
But I thought if it was in the bracket, yeah, you said that they can't. No, it doesn't apply to the one because.
So This one, oops,
I remember it.
the one right before a number does count. So this one applies to this fraction, but doesn't apply to the other one, right? Right? Okay. Did you get the right answer?
Yeah.
Yeah? Okay. Okay. We'll do the next one and it'll help clarify them.
Would that be positive ones? Yeah.
Okay. So the next question I wanted, and some of you guys probably do yourself, but I just want to make sure that I highlighted the fact of the negatives here. Is we have a negative here, and negatives all over the place. This negative and this negative can't be canceled out, right? This negative and the number, the negative in front of it, can be combined, or any other negative on the same fraction. So those two negatives can combine to make a positive 12 over 15. Right? Now, we can do the same thing. This negative and this negative, two negatives make a positive, right? Can be combined to make a positive 11 over 6. Right? Now, here I didn't write down a plus sign. This is positive, you typically don't do that. Over here, if I don't put a plus sign, all of a sudden I just have two fractions sitting next to each other. And it looks like they're multiplying, but that's not the case. We actually need to have that plus sign in between, right? And that's what I really wanted to highlight there, right? Okay. So if the plus sign is in between two numbers, yeah, we need to show it. If it's at the beginning, we already know it's assumed to be positive. Okay, so now we look at this, and these are not so nice numbers, but maybe you can see what is a common denominator between 15 and 6. Sadie? 30. Oh, excellent. So 15 times 2 gives us 30. So the first one becomes 24 over 30. And 6 times 5 becomes 30, which is 55 over 30. And we combine this together. What's our denominator? What's our numerator? 79. Okay. Can that be reduced? I don't think so. No, I think 79 is a prime number, so that can't be made smaller. Okay. So that's just adding and subtracting. So we're gonna skip this working backward questions and just do the two word problems. Okay? Yeah. Okay. So on 1 January day in Prince George, the temperature read negative 10.6 degrees Celsius at 9 a.m. in the morning, and by 4 p.m. it read 22.4 degrees Celsius. Is asking for part A, what is the temperature change? Okay, the word change is a specific calculation in which you may already know. You're going to do a lot of changes next year in science and math, right? Yeah, it is subtraction. So the word change, right, means your final subtracted from your initial, right? That it's a difference between where you started off from and where you ended up, but it's always final minus initial, right? So we plug in what is our final temperature of the day. 2.4. We got that from here. Then we subtract our initial temperature of the day. Which was that? So negative 10.6. So I'm going to put that 10.6 in brackets with the negative there. Okay. So what is our change? 13, yeah. So you remember that two negatives make a positive. That ends up being 13 degrees Celsius. Right? So remember to include units. So these values have units attached to them. We're talking about temperature, so that's degrees Celsius. Okay. Now rate, second question is asked, find the average rate of change in temperature. Now rate is a very scientific term and is always done by the same calculation. Rate is always your change that occurred divided by the time it took for that change to occur. So that tells you how fast that change is happening. Yes. Okay. So in our first step, we calculated what the change was. We said it changed 13 degrees. Next question is, how long did it take for that change to take place? Well, it started at 9 and it went to 4 p.m. How many? 7 hours. So we go 13 divided by 7 on our calculators. What do we end up with? 1.8? Do we need to round that?
Well, it's 1.85, so you could round it to 1.9.
Yeah, so 1.85, let's round that to 1.9. Okay? So this should have units. What are the units for this? Yes or no?
Would it be like 1.9 degrees per hour? Or?
Yeah, 1.9 degrees Celsius per hour. So our numerator was degrees Celsius. Our time was in hours. So our units is degrees Celsius per hour. The top unit, per means divide, bottom unit. Right, that's where that comes from. So if this was a change in like distance, you're seeing how far somebody went, it would be like kilometers per hour or something like that. Right? So something, if I ask you for change at this year, I'll probably help you along the way. Next year, you can do lots of rates and change calculations. Okay, final word question of the day. Okay, we have the Rodriguez family who has a monthly income of $6,000. They budget 1/3 of their for food, and they budget a quarter for rent. Oh, we're gonna run out of clothing. A fifth for clothing, and finally a tenth for saving. How much money is left over after they spend all the things they have to spend money on?
Oh, brother, so we have to find like all of the fractions.
Yeah. So remember the word. You think of the word of. So a third of 6,000 is what they're using for food. So a third of means multiply of 6,000 is what they spent on food, which is 6,000 divided by 3 should be $2,000 a month on food.
Is that good or bad?
Depends on how big your family is.
Apparently, it's a large family.
Right? I've right now my bill is not too bad monthly, but my boys are young. When they get older, it's gonna be a lot of food, right? We eat meat in my household, so one of the cost saving things we do is I have a friend who has a hobby farm, so we buy a side of beef and we have it in the freezer to help reduce costs and stuff like that. Yeah. Okay, rent. A quarter of their $6,000 goes towards rent. So $6,000 divided by 4. That should be a nice round number. 6,000 divided by 4.
I thought you were multiplying.
Oh, yeah. So you can multiply by a quarter, or you can think of this as if you multiply the tops together, you end up with 6,000 over 4. Right? Then you have to divide.
So we're just dividing.
In this case, you end up dividing. I did 2 steps in my head. I did this step in the head. Okay, multiply the tops together. We end up with 6,000. Multiply the bottoms together. Remember, this is over 1. 4 times 1 is 4. So we end up with 6,000 over 4. We don't want to leave. We're talking about money here, so we don't leave it as a fraction. You divide those two things together. It was $1,500, which is probably about average admission for $1,500 to $2,000 is what people I think pay for rent for like a family size house. I think. Finally, okay, clothing. A fifth for of the $6,000 for clothing. All right, so multiply the tops together, multiply the bottoms together, you end up with 6,000 over 5. But since we're talking about money, we won't leave that as a fraction. Yes.
Could you just do divided by 1,000?
Sorry, I couldn't hear.
Actually,
Okay. So you go 6,000 divided by 5. 6,000 divided by 5 is $1,200 a month on clothing.
money on clothes a month.
For a family, I guess.
They're getting a lot of new clothes all the time.
Yeah.
Yeah. I mean,
I don't know. Yeah. I don't think my family spends that much money on clothing. That's like what, $14,000 a year on clothing? That's a lot of money on clothing.
No, I don't think so. I mean, Charlotte, spent 1/3 of $1,200 in this month, so to herself.
Yeah.
I don't do that every month.
Yeah, that's the whole thing. It's not every month, right? So, okay, a tenth goes towards savings. So, 1/10 of $6,000. So, multiply the tops together, multiply the bottoms together. We end up with 6,000 over 10. So, 6,000 divided by 10, $600. All right. So, how much money have they spent altogether? So, you add up all those numbers. Add them up. What do we get?
Sounds like a very organized.
Yes, Malia.
Unlike
5,300. Thank you. So altogether, when we add these up, we end up with 5,300. Okay. Does that answer our question?
No.
No. What is our question asking?
How much is left over?
So how much is left over?
700.
700. We go $6,000 is our income. We spend 5,300. We end up with $700 left over. So word problems. Give a statement. Right? Amount left over is $700.
I make a lot of that.
It's expensive.
No,